So whenever a problem connecting root of 1 plus x or root of 1 minus x like that are given, we have to rationalize, that's it. The value of limit when x tends to infinity of 1 by x is always equal to 0. Divide both numerator and denominator by highest degree term. Now we know that since 1 plus 2 plus 3 sum of n terms is always equal to n into n plus 1 divided by 2. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed the problems based on the theorems limit x tends to e of x raised to n minus a raised to n by x minus a is equal to n to the power of n minus 1 and limit theta tends to 0 of sin theta by theta is equal to 1. Now, so I am going to take a few more problems based on those exercise. And also today I am going to discuss to evaluate the limits whenever n tends to infinity or x tends to infinity. Right. Now, let us come to the first problem. This is very important. So, you may expect this type of questions for your final examination. So, limit x tends to 0 of 1 plus x minus 1 divided by x. Now, suppose if you put x is equal to 1, by putting x is equal to 1, by putting x is equal to 0, then this becomes root of 1 plus 0 minus 1 by 0. So, root of 1 plus 0 is root 1 is 1 minus 1 by 0, 0 by 0 form, which is an indeterminate form is obtained. So, whenever a problem like this given, we have to rationalize. Just multiply both numerator and denominator by root of 1 plus x plus 1, rationalizing the numerator. So, that is limit x tends to 0 of, you just keep this as it is, root of 1 plus x minus 1 divided by x, multiply by root of 1 plus x plus 1, divide by root of 1 plus x plus 1. That is rationalizing the numerator. Multiply both numerator and denominator by root of 1 plus x plus 1 by root of 1 plus x plus 1. Now, multiply this. This is equal to limit x tends to 0 of root of 1 plus x into root of 1 plus x is root of 1 plus x whole the square minus 1 into 1 is 1 divided by, in the denominator you will get x into root of 1 plus x plus 1 as it is. Now, your square and square root gets cancelled. What is left over is limit x tends to 0 of 1 plus x minus 1 divided by x into root of 1 plus x plus 1. Now, here minus 1 plus 1 gets cancelled. This is equal to limit x tends to 0 of, what is left in the numerator is x divided by, in the denominator same x into 1 plus x plus 1. Now, cancel the terms which gets cancelled, x and x gets cancelled. What is left over is 1 over root of 1 plus x plus 1. Now, apply the limit. If you put x is equal to 0, 1 by root of 1 plus 0 plus 1, that is 1 by root of 1 plus 0 is root 1, root of 1 is 1 plus 1, that is equal to 2. So, 1 by 2 is the simplified answer. That's it. Very simple problem. Okay. So, whenever a problem connecting root of 1 plus x or root of 1 minus x like that are given, we have to rationalize. That's it. So, rationalizing the numerator, multiply both numerator and denominator by root of 1 plus x plus 1. So, root of 1 plus x minus 1 into root of 1 plus x plus 1 is root of 1 plus x whole square minus 1 divided by, the denominator is same, x into root of 1 plus x. So, square root gets cancelled, we will get 1 plus x minus 1 in the numerator. This is minus 1 plus 1 gets cancelled. So, what we have in the numerator is x, denominator is same, x and x gets cancelled, 1 by, put x is equal to 0, 1 plus root of 1 plus 0 plus 1, root of 1 plus 0 is 1. So, 1 by 1 plus 1 is equal to 2. So, the evaluated answer is 1 by 2. That's it. Okay. Very simple and very important type problem. Hope you followed. Now, let us come to the same type problem. Let us take this problem, a similar type problem. So, limit x tends to 0 of root of 2 minus x minus root of 2 plus x divided by x. Suppose if you put x is equal to 0. If you put x is equal to 0, then this becomes root of 2 minus x minus root of 2 plus x is 0 divided by 0, that is root of 2 minus 0 is root 2 minus root 2 divided by 0, 0 by 0 form, which is an indeterminate form is obtained. Here also rationalize the numerator, that's all. So this can be written as limit x tends to 0 of root of 2 minus x minus root of 2 plus x divided by x. For this, just multiply and divide by root of 2 minus x plus root of 2 plus x divided by root of 2 minus x plus root of 2 plus x. So, rationalizing the numerator, this is equal to limit x tends to 0 of multiplied root of 2 minus x into root of 2 minus x is root of 2 minus x whole square, minus into plus minus root of 2 plus x into root of 2 plus x is root of 2 plus x whole square. In the denominator, x into root of 2 minus x plus root of 2 plus x. Now, square root gets cancelled. Simplify, you will get the answer. That's it. See, listen to me here. By putting x is equal to 0, we will get 0 by 0, which is an indeterminate form. Just rationalize the numerator, multiply both numerator and denominator by root 2 minus x plus root 2 plus x. Root 2 minus x plus root 2 plus x by root 2 minus x plus root 2 plus x. Root 2 minus x into root 2 minus x is root 2 minus x whole square. Minus into plus minus root 2 plus x into root 2 plus x is root 2 plus x whole square divided by the denominator is same x into root 2 minus x plus root 2 plus x. Square root gets cancelled, and what is left over is this is equal to limit x tends to 0 of 2 minus x minus this is 2 plus x divided by denominator x into square root of 2 minus x plus root of 2 plus x. Now, cancel the terms which gets cancelled. Let us multiply first. Limit x tends to 0 of 2 minus x as it is, multiply by negative sign minus 2 minus x divided by x into this is 2 minus x plus root of 2 plus x. So, here plus 2 minus 2 gets cancelled. What is left over is limit x tends to 0 of what is remaining terms minus x is minus 2x divided by denominator is same x into 2 minus x under root plus root of 2 plus x. Now here x and x gets cancelled. This is equal to limit x tends to 0 of, in the numerator we have minus 2 divided by, in the denominator 2 minus x plus root of 2 plus x. Now substitute the value of limit, put x is equal to 0. This is minus 2 divided by 2 minus 0 plus 2 plus 0. This is minus 2 divided by 2 minus 0 is 2, 2 plus 0 is also equal to 2. So minus 2 divided by root 2 plus root 2 is 2 root 2, and 2 gets cancelled. This is equal to minus 1 by root 2. So the simplified answer is minus 1 by root 2. That's it. Okay. Hope you followed. Just rationalize it. After rationalizing, cancel the terms which gets cancelled. Here 2 minus x minus 2 plus x multiply by negative sign minus 2 minus x divided by denominator is same. So here minus 2 plus 2 gets cancelled, minus x is minus 2x, again x and x gets cancelled in the numerator and denominator. So what is remaining? The remaining terms are minus 2 by root 2 minus x plus root 2 plus x. Substitute the value of limit, put x is equal to 0, then minus 2 divided by 2 minus 0 is 2, 2 plus 0 is also 2, root 2 plus root 2 is 2 root 2, 2 gets cancelled, you will get minus 1 by root 2 as the simplified answer. That's it. Now let us come to this problem. Evaluate limit x tends to 2 of x square minus 4 divided by root 2 plus x plus root 2 minus root of 3x minus 2. So here also if you put x is equal to 2, 2 square is 4 minus 4 divided by 2 plus 2 is 4 minus 3 to the 6 minus 2 is 4. Root 4 gets cancelled. We will get 0 by 0 form. By putting x is equal to 0, we will get 0 by 0 form, which is an indeterminate form. Now therefore this can be written as limit x tends to 2 of, this numerator is same, x square minus 4 divided by, in the denominator x plus 2 minus root of 3x minus 2. For this just multiply both numerator and denominator by root x plus 2 plus root of 3x minus 2, that is rationalizing the denominator. same root of x plus 2 plus root of 3x minus 2. Rationalize the denominator. So this can be written as limit x tends to 2 of numerator x square minus 4 as it is into root of x plus 2 plus root of 3x minus 2 whole divided by, in the denominator, root of x plus 2 into root of x plus 2 is root of x plus 2 whole the square, root of x plus 2 whole square, minus into plus it is minus, root of 3x minus 2 into root of 3x minus 2 is root of 3x minus 2 whole the square. So this is equal to limit x tends to 2 of x square minus 4 into, this is same, root of x plus 2 plus root of 3x minus 2 whole divided by, here square and square root gets cancelled, x plus 2 minus 3x minus 2. Now let us multiply, the numerator is same, multiply the denominator by negative sign. Now therefore this can be written as limit, in the numerator x square minus 4 can be written as 2 square, x square minus 2 square into, the remaining steps are same, root of x plus 2 plus root of 3x minus 2 whole divided by this x plus 2 multiply by negative sign minus 3x minus into minus plus. So this is equal to limit x tends to 2 of, this can be written as a square minus b square is a plus b into a minus b, x plus 2 into x minus 2 into remaining steps x plus 2 plus root of 3x minus 2 whole divided by, in the denominator 2 plus 2 is 4, x minus 3x is minus 2x. Now this can also be written as limit x tends to 2 of, in the numerator x plus 2 into x minus 2, and this term is same, x plus 2 plus root of 3x minus 2 whole divided by, in the denominator, so you can take 2 common factor, 2 out, what is left is 2 minus x. So this 2 minus x can also be written minus x plus 2 or minus of x minus 2. So this will get cancelled, that's equal to limit x tends to 2 of x plus 2 into x minus 2 into root of x plus 2 plus root of 3x minus 2 whole divided by, denominator 2 into 2 minus x can also be written as minus of x minus 2. Now cancel the terms which gets cancelled, x minus 2 gets cancelled, and apply the limit. So if you apply the limit, x is equal to 2, 2 plus 2 is 4 into root of 4 plus root of 3 2s are 6 minus 2, 6 minus 2 is 4 divided by minus 2. This is 2 2s are gets cancelled, minus 2 into root of 4 plus root of 4 is, root of 4 is 2 plus 2, that's equal to 2 plus 2 is 4, 4 into 2 is 8. The simplified answer is minus 8 is the simplified answer. That's it. Hope you followed. Very simple. Just cancel the terms which gets cancelled and substitute the value of the limit, you will get the answer. That's it. Very simple problem indeed. Okay. Let us come to the next concept. The next concept is to evaluate the limits whenever x tends to infinity or x tends to 0. So however small the value of x, either it may be positive or negative infinity, before that we know the value of this, the value of 1 over x, when x tends to infinity, 1 over infinity, 1 by infinity is always equal to 0. Similarly, 1 over infinite square, 1 over x square, 1 over infinity square is also equal to 0. Suppose if it is 1 over 0, 1 over 0 is equal to infinity, and 1 over 0 square means that's also equal to infinite. Now using this concept, limit x tends to infinity, the value of limit x tends to infinity of 1 over x. 1 over x means 1 over infinity is always equal to 0. So the value of limit when x tends to infinity of 1 by x is always equal to 0. This is very important concept. limit x tends to infinity of 1 over x is always equal to 0. Similarly, if you put x square as infinite square, this is also equal to 0. So the value of limit x tends to infinity of 1 over x square is always equal to 0. 1 by infinity or 1 by infinity square is always equal to 0. Now let us come to the next concept, 1 by x. So the value of 1 over x here, 1 over 0. 1 by 0 is always equal to infinity. Limit x tends to 0 of 1 over x is equal to infinity, and similarly limit x tends to 0 of 1 over 0 square. 1 over 0 square is also equal to infinite. So these four concepts are very important to solve the problems. Whenever x tends to 0, or x tends to infinity, or n tends to 0, or n tends to infinity. Limit x tends to 0 of 1 over x is infinity. Whenever x tends to 0 is also equal to infinity. Usually we will get the problems like this: 1 over n tends to infinity of 1 by n. Limit n tends to infinity of 1 over n. 1 over n, 1 over infinity is 0, and similarly limit n tends to 0 of 1 over n. 1 over 0 is also equal to infinite. These are the concepts which we are going to use to solve the problems whenever n tends to infinity or x tends to infinite. Now let us take a simple problem. Now limit, evaluate, this is very important type of problems. Evaluate limit x tends to infinity of 3x square minus 4x plus 2 divided by 2x square minus 5x plus 7. Now let us divide both numerator and denominator by highest degree term. So here the degree of x in the numerator is 2 and the degree of x in the denominator is also 2. So divide both numerator and denominator by x square. Divide by x square both in numerator and denominator. Then this becomes limit x tends to infinity of term by term division. 3x square by x square minus 4x divided by x square plus 2 by x square whole divided by 2x square divided by x square minus 5x divided by x square plus 7 divided by x square. So divide both numerator and denominator term by highest degree term, that is x square. Now that is equal to limit x tends to infinity of square x square gets cancelled 3, 1 x and x gets cancelled 4 by x, and this is equal to 2 by x square whole divided by the denominator x square gets cancelled 2 minus 1 x and x gets cancelled 5 by x plus 7 by x square as it is. Now let us apply the limit for this. Now since you know the limit, since we know that limit x tends to infinity of 1 over x is equal to 0. Similarly, limit x tends to infinity of 1 over x square is also equal to 0. If you apply the limit, then this is 3 minus 1 by infinite. 1 by infinite is equal to 0. 1 by infinity square is also 0 divided by 2 minus 5 by infinity is equal to 0. 7 by infinity square is also equal to 0. That's equal to 3 by 2. The simplified answer is 3 by 2. Usually we will get the values of highest degree term 3 by 2. So the simplified answer for this is 3 by 2. That's it. Very simple problem. Just divide each and every term in numerator and denominator by x square, and then apply the property of this limit. Limit x tends to infinity of 1 over x is 0. Limit x tends to infinity of 1 over x square is also equal to 0. Then these terms become 0. 3 minus 0 plus 0 by 2 minus 0 plus 0, that is nothing but 3 by 2. So the simplified answer is 3 by 2. That's it. Hope you followed. Now let us take a similar type problem. Okay. Now let us come to this. Here the limit x tends to infinity of 3x square minus x divided plus 5 divided by 7x minus 5. The degree of numerator is 2, degree of denominator is 1. So the numerator is greater than the denominator. So if you want straight away, you can divide by x square. Now divide by x square both in the numerator and denominator. Limit x tends to infinity of term by term division, 3x square divided by x square minus x by x square plus 5 divided by x square whole divided by 7x divided by x square minus 9 by x square. Here one x square and x square gets cancelled. Limit x tends to infinity of x square and x square gets cancelled. 3 minus 1 by x plus 5 by x square whole divided by, in the denominator 1 x gets cancelled, 7 by x minus 9 by x square. Same concept, since we know the value of limit x tends to infinity of 1 over x is equal to 0. Limit x tends to infinity of 1 over x square is also equal to 0. So if you apply the limit, this is 3, 1 over infinity is 0, 1 over infinite square is also 0. This is 7 by 7 out, 1 by infinity, this is also 0, minus 0. So 3 divided by 0, you will get the answer as infinite. That's it. Okay. Hope you followed. That's it. See, just divided by x square, then you will get in the numerator 3 minus 1 by x plus 5 by x square, denominator 7 by x minus 9 by x square. Apply the limit. So 3 minus 0 plus 0 by 0 minus 0, that is 7. 3 divided by 0, that's equal to infinite. That's it. Or this can also be solved using another method. Now, second method. To solve the same problem, we can limit x tends to infinity of, so you can take a 3x common factor here. If you take 3x square out, then this become 1 minus x by 3x, that is x divided by 3x means you will get 1 divided by 3x plus 5 divided by 3x square. In the denominator, you can take divide by 7x, 1 minus 9 by 7x. Now here 1x and x gets cancelled. Limit x tends to infinity of 1x and x gets cancelled. 3 by x, 3 by 7 out. And what is left in the numerator is x into 1 minus 1 by 3x plus 5 by 3x square divided by, in the denominator 1 minus 9 by 7x. Now apply the limit. If you apply the limit, 3 by 7 is a constant into, put x is equal to infinity into, this is 1 minus 0 plus 0 divided by, in the denominator 1 minus 0. 3 by 7 into infinity into 1. Any number multiplied by infinity is equal to infinite, we will get. That's it. This is how we can also solve the problem. This is the second method. Hope you followed. You can do any method to solve this problem, right? Now, what is the problem given? This very important problem. Evaluate limit n tends to infinity of 1 plus 2 plus 3 plus etc. n divided by 2 into n plus 5 whole the square. Now, we know that since 1 plus 2 plus 3 sum of n terms is always equal to n into n plus 1 divided by 2. Sum of n terms. So, let us apply this formula for this. Limit n tends to infinity of 1 plus 2 plus etc. n is n into n plus 1 divided by 2 into this as it is, that is 2 into n plus 5 whole the square. So, this can be written as limit n tends to infinity of n into n plus 1 divided by 2 into 2 is 4 into n plus 5 whole the square. So, you can simplify this. This can be written as limit n tends to infinity of n into n is n square plus n into 1 is n divided by 4 into, just simplify this, apply a plus b whole square, n square plus b square 4 into 5n plus 5 square 25. So, this can be written as limit n tends to infinity of n square plus n divided by, multiplied 4n square plus 5 4s are 20, 20 into 4, 80n plus 25 into 4 is 100. Now, divide both numerator and denominator by the highest degree term, that is n square. Then what it is equal to? Limit n tends to infinity of 1 plus 1 by n divided by 4 plus 80 divided by n plus 100 divided by n square. Now, apply the limit, that's all. So, if you apply the limit, what you will get? This is limit n tends to infinity of, what we have in the numerator, 1 plus 1 by n divided by, in the denominator 4 plus 80 by 4, 80 by n plus 100 by n square. So, this is equal to 1 plus 0 divided by 4 plus 0 plus 0. This is equal to 1 by 4. The simplified answer for this is 1 by 4. That's it. 1 by 4 is the value of this limit. That's it. This is how we are going to solve the given problem. So, that's all regarding today's session. Let us meet with the different concept in the next session. Hope you followed this problem, practice this. That's all regarding today's session. Thank you very much.